So what we're going to be doing is going to the next part of linear programming. So this is now going to be us taking what we learned in the last lesson and actually applying it in this lesson. So last lesson we gained a general understanding of the basic concept of linear programming. However, now what we need to look at is if we get a question that is descriptive in terms of having text, how do we convert that text into algebraic inequalities? And then we need to know how to do it the other way around, how to convert those algebraic inequalities into descriptive text. Okay, so I want y'all to take down these objectives. So the first thing we want to do is convert descriptive constraints into inequalities and vice versa. We want to determine the feasible region of a set of inequalities like what we did last time. And then obviously we want to determine the optimum solution of that particular feasible region. So let y'all write the objectives, then after we continue from there. Alright, so we have to convert descriptive constraints into inequalities. Okay, so looking at this, we need to figure out what would be these here written as inequalities. Okay, so I'll go through this one with you to give you an idea how this goes, and then you try to do one on your own and see how you do. So looking at this one here, it says X represents the number of mangoes. So over the number of mangoes, I'm gonna put X. All right, notice what it says. X represents the number of mangoes. So whenever I see number of mangoes, what comes to mind should be what?
X.
X. Excellent. And Y represents the number of bananas. So anytime I see number of bananas or any reference to bananas, what should I think of?
Y.
Y. Excellent. So the total number of bananas and mangoes. Okay, so the total number of bananas and mangoes must be less than or equal to 7. So I'm going to try to convert this sentence into inequalities. So the first thing I'm going to look at is bananas. What did I say bananas represents?
Y.
Y. So I'll put over this Y. And then this here, what does mangoes represent?
X.
So I'll put X here. The total number of bananas represents Y, and mangoes would be X. So it says must be less than or equal to. So less than would be this, or equal to meaning like this sign. So this means less than or equal. So right here is less than or equal. So that's what this sign means. And it's less than or equal to what?
7.
7. So look at that. So it says the total number of bananas and mangoes must be less than or equal to 7. So I want to know, if I'm saying bananas and mangoes, what mathematical symbol can I use for the word and?
Plus.
Lovely. So if you look at that, I could essentially say, the first one for this must be X plus Y is less than or equal to 7. Now, does that make sense?
Yes.
Now check this out. What did we say X represents?
Mangoes. Mangoes.
The number of mangoes. What does Y represent?
Bananas.
The number of bananas. So check this out now. If I was to convert this back, since X means the number of mangoes and Y means the number of bananas, look how I read this now. So X means the number of mangoes and the number of bananas. Y'all following me?
Yep.
Is less than or equal to, I'm literally reading the signs, is less than or equal to 7. So the number of mangoes and the number of bananas is equal to and less than 7. So what this is saying is that if you have to go and get bananas and mangoes, it has to be less than or equal to 7. Okay? Now, let's look at this one here now. It says the number of bananas. What did we say represents the number of bananas?
Y.
So Y must be more than. So what kind of sign we could put here? What means more than? This right here. And the number of mangoes represents what?
X.
X. So y'all notice what I did here? Literally, I'm just writing the letter and the signs, or the inequalities rather, over the word that spells it out. So for instance, the number of bananas, I'm just writing Y over it, must be more than, so more than the number of mangoes. So then all I would have to put here is another inequality is Y is more than X. Does that make sense?
Yep. Yeah.
Beautiful. Now, because we have a number of bananas and number of mangoes, we cannot have negative mangoes or negative bananas in a literal sense. Okay? I can't walk to the shop and say, oh, I want to buy -3 bananas. Somebody gonna watch you like you're crazy. Right? So because of that, I know that the value of X, or the number of mangoes, must be more than or equal to what number? What number you think this must be equal to or more than? 0. Because you could have 0 mangoes or more, but you can't have less than that. You follow me now? Alright, likewise for Y, the number of bananas must be more than or equal to 0 as well, because we cannot have less than 0 mangoes. I can't say, oh, I got -1 bananas in my house. You understand? So that's why we have to put that. Does that make sense so far?
Yeah.
So just to summarize, we're saying the number of mangoes and the number of bananas must be less than or equal to 7. So that's literally what this sentence says. X represents the number of mangoes and Y represents the number of bananas. Okay? Now it says the total number of bananas, which would be Y, and mangoes must be less than or equal to 7. Literally our first line here. And then it says the number of bananas, Y, must be more than the number of mangoes, X. Okay? So let's try it for this one now. It says 1 mango costs $1. So therefore, if I have 1 mango, that would be $1 times the number of mangoes, which is X. So if I have 2 mangoes, it's going to cost me 2 times 1, which is $2. If I have 4 mangoes, it's going to cost me how much?
$4.
Lovely. Now it says 1 banana costs $3. So that means for every banana is going to be $3. So if I have 1 banana, it's going to be $3. What's going to happen if I have 2 bananas?
$6.
$6. Lovely. Y'all catch the point. Now, I covered this. So 1 mango, so X times 1, because I don't know what X is. X could be 10, you could have 5, 20, who knows how many mangoes we have. But then again, it must be less than or equal to 7, right? So, and 1 banana costs $3. So I could have 1 banana, 2 bananas, who knows? But what I'm saying here is that each banana that I have will cost $3. Now it's saying here the buyer should spend no more than $12. So no more is telling me that I have a restriction or a constraint. No more means less than or equal to. Okay, so less than or equal to $12. All right, so this is what we have here for that, and we cannot forget these two here as well. Okay, these two are very important. All right, so I want y'all to take down this example and put it in your books, because this is very critical for understanding how to convert these descriptive equations or these descriptive texts into inequalities. Because sometimes you may know how to calculate it, you may know what to do, but what you need to know for sure is how to actually work this out and convert it to this. Yeah, so remember to write the text and then the answers, inequalities. All right. So, this question 2, I want you to try and answer this one. So, I want you now to look at this question and see if you are able to come up with the inequalities to match this text. Careful with your signs. Remember, we have several different signs. Okay? So, we have less than, we have more than, we have less than or equal to, we have more than or equal to. Okay, so choose your signs carefully. Sometimes they come in different forms. Sometimes it says no more than, no less than, at least, at most. All right, so let's look at this, right? So we said the total number of bananas and mangoes must be at least 10. So the total number of bananas. So bananas represents here what? Y. And then and means lovely. Mangoes represent X, which must be at least 10. So must be at least 10. What does that mean? What sign?
Higher than or equal to?
More than or equal to, lovely. And then 10. Okay. So the number of bananas, which represents what? The number of bananas would be Y, which must be less than or equal to twice the number of mangoes. So the number of mangoes would be x. So y is less than or equal to 2x. So the number of bananas must be less than or equal to 2x. Now remember, obviously, since we are counting mangoes and that kind of stuff, we know that x must be more than or equal to 0, and y also must be more than or equal to 0. Okay? Now, with this last part, it says 1 mango, so we know that it should be like saying 1 mango. So 1 mango is $1. Okay, so $1 times x, and, which is plus, 1 banana, which is $5, so 5 bananas, so 5y. So 5y, the buyer should spend no less. So if you're spending no less, it has to be more than or equal to 15. All right, 15. Does that make sense? Getting easier now?
Yep. Yeah.
Lovely. So this is what we're looking at right here. So we have this here right now. Okay, now this here is as if we have a full question. So you're gonna have here something asking you to do the constraints. So the first part represents the constraints, and the last part represents the objective function. Let's see what y'all get when you put this together. All right, so the trick is, right, you just have to kind of look at this in sections. So it says here, Mira wants to buy X fish and Y chickens, which she plans to bring to our class cookout in her cooler. When I see X, all I think to myself is fish. When I see chickens, all I think about is Y. So that being said, I just go like, she is. I do not care about this, she is. I do not care about this, she is. Bring in. I don't care what she bringing right now. Okay, so this here is irrelevant to me. What I concern is the word fish. What does fish represent?
X.
X. And this here represents what? And represents what? Plus. So x plus, what does chickens represent?
Y.
All right, so you see what I have already? X plus y, nothing else. Okay, but has space for only 25. If I tell you I only have space for 25, what do you understand by that?
As a constraint.
That's a constraint. You can't have more than 25 inside of that freezer. Okay, so that means that's a limited resource. And if that's a limited resource, clearly that means that x plus y cannot go beyond 25. So space for only means less than or equal to, and then 25. Okay, all of this here unnecessary, right? This is just extra fluff. Okay, now x plus y less than or equal to 25. So that's our first constraint. X plus y less than or equal to 25. Does that make sense?
Yeah. Yep.
Now look at this part. In order to satisfy the class, does that sound important to you?
No.
No. So I can get rid of that. I don't need this. What's the next part? She must bring at least 7 pieces of fish. Okay, so I know that fish represents what?
X.
X. So bearing that in mind, I know that I need to make sure that I replace the fish with X. So when I see fish, that means X. And then the next thing here now, it says it must bring at least. So at least means more than or equal to 7. Okay, so for this one, she must bring pieces of fish. So I know the fish is going to be X for the number of fish, and that has to be more than or equal to 7. So y'all notice how I'm doing that? Not bad at all, right? So let's look at this next one. The number of chickens. What represents chickens?
Y.
Y. So all I have to do is replace chickens with Y. And it has to be less than. So it must be less than twice. What represents twice?
2.
2. And then the number of fish represents what?
X.
X. So now I have Y less than 2x. So I would say y less than 2x. So if I had to convert that to words, I would be saying y, which represents the number of chickens is less than 2 times or twice the number of fish. Okay? Now, the last one. The class plans to sell each fish for $7 and $6 for each chicken. So each fish is x, and each chicken is y. So determine the formula for the objective function to obtain the maximum possible profit. So I'm going to say profit is P which is equal to, so it says we're selling each fish for $7. So that means $7 times the number of fish. So if I have 2 fish, it's going to be 7 times 2. If I have 5 fish, it's going to be 7 times 5. On the next end, I have to add that now to $6 for every chicken. So $6 for every chicken. So 6 times the number of chickens. So the number of chickens would be whatever chickens she has in the cooler. Okay, so this here is an objective function, all right, that we would have. And remember, based on our previous video that we did, once we have these constraints, we plot them on a graph, we get our feasible region. After we get our feasible region, we find our vertices, and once we find our vertices, we plot them inside of this equation, which is the objective function. All right, so guys, if you didn't get what I got, put this down, okay, and just go through it. You have to go over these things to get it. It's not something that you get overnight, but if you go over this enough times, it starts to stick. All right, so this one here, take this out. Remember, maths is all about practice, guys. The more you go over something, it becomes repetitive. It starts to look easier. The first time you go over it, it might have you thinking, what is this? What's going on? I don't understand this. What's happening here? But as you keep going through it, you start to get better at it. All right, so I'll give you all this one to try on your own. And then after this, we will go through the process of a full question. And then we'll break down straight to the objective function. So let's see how y'all come up with this one and what you do for this. All right, so let's go through this one now. So with this one, as you can see, it says for every box of watches packed by a company, they pack W waterproof watches and O oil-proof watches. The number of oil-proof watches, so this whole thing here represents O, must be at least, so O must be at least half the number of waterproof watches. So half is written as 1/2, and we know the number of waterproof watches is basically W. So we would say here O is more than or equal to half W. And that's the first one. So the next one says there must be at least 5. So at least 5 is at least 5 waterproof watches. So waterproof watches is represented by W. So W must be more than or equal to 5. Okay, so literally I'm converting this text into these. So the next part says the number of watches must not exceed 14. So remember, we have 2 types of watches here. We have waterproof watches and oil watches. So that must mean that 2 watches put together, so W plus O, cannot exceed, so must be less than or equal to 14. Lovely. So that is it for our constraints. Now we need to look at the profit objective function in this case. So it says the water and oil proof will cost $70 and $80 respectively. Determine a formula for the objective function to obtain the maximum possible profit. So then what's going on here is that we have $70, so profit is equal to 70 times W plus 80 O. Now how do I know is that? Because 70 is first, and it says water is first, and then oil proof. Remember, it says respectively. So respectively is just telling us in that particular order. Okay, so in that particular order, we have water first, followed by the oil, and therefore water here matches with 70, so therefore oil would match with 80. Alright, so that's something to bear in mind. Okay, so if you didn't have this, just take this down, and then after we go through an entire process, an entire phase, so you could see what it is like to start from turning the descriptive text into inequalities, and then plotting the inequalities, identifying the feasible region, then identifying the vertices, then using the objective function to find the solution that best suits all the constraints. Alright, so this is what we have here now. So we say that X represents the number of fruit trees in a garden, Y represents the number of vegetable trees in a garden. So we have to write a set of inequalities to represent each constraint and an equation for the objective function. So the number of trees must be equal to or more than 6. So the number of trees is represented by what? We have fruit trees and vegetable trees. Okay, so therefore it should be X plus y, because this represents the total number of trees, has to be equal to or more than 6. Alright, so therefore it has to be more than or equal to 6. So then the next part says the number of vegetable trees, which is represented by y. So y must be less than or equal to, so y is less than or equal to twice the number of fruit trees. So twice the number of fruit trees. So 2x. So y is less than or equal to 2x. Now the last part, it says 60 hours are available to walk in the garden. So we have 60 hours available to walk in the garden per week. So basically, if you have 60 hours available to walk in the garden per week, that shows there's some form of a restriction. Okay, so you're restricted to 60 hours a week. So you can't go past 60. Now it says only 4 hours are allowed for each fruit tree. So that means 4 hours for each fruit tree would be 4x, because fruit tree represents x, and then we have 5 hours for each vegetable tree. So vegetable tree represents y. So 4x plus 5y must be less than or equal to 60. Why? Because 4 hours is available for each fruit tree and 5 hours available for each vegetable tree, and this has to be less than or equal to 60, because 60 is the only available hours that we have to walk in the garden per week. So these are the 3 constraints that we have, and obviously we know x must be more than or equal to 0 and y must be more than or equal to 0. Now the last part is the objective function. It's asking for the maximum profit. So profit is equal to fruit trees and veg trees cost $10 and $15 respectively. So the fruit is 10 and the vegetable is 15. So therefore I know it has to be 10x, because x is the fruit trees, plus 15y. Okay, so that here represents the profit. Okay, so this is what we have so far. Does that make sense?
Yep.
Lovely. Now the next thing that we need to do is to determine the coordinates of the x and y intercepts. So we have to do that for each of these. Okay, so this is something that we did last time. So it's the same exact process. Okay, so let's go through them. We'll do these where we get the coordinates for these. Alright, so the first one that I have here is x plus y for 6. Okay, now we need to figure out the x and y intercepts. So x plus y, we know that x, we start off with that being equal to 0. So we substitute, replace that x with 0 plus y, which is equal to 6. So therefore, when x is equal to 0, y is equal to 6. So my coordinate for x plus y equals 6, the first coordinate is going to be 0, 6. Okay, 0, 6. Now the next thing is we have to find it for when y is equal to 0. So when y is equal to 0, okay, when y is equal to 0, we say that x plus 0 is equal to 6, because I'm substituting the y with 0. So y here is getting replaced with 0. Now x plus 0 is just x, which is equal to 6. So therefore, I know that the coordinate for this is going to be 6, 0. So y'all remember when we did this?
Yeah.
Lovely. So the next one we need to look at, the next constraint is going to be 4x plus 5y for 60. So we're checking that line. So we replace x with 0 first. This here gives us the y-intercept, guys. Remember that. So 4x means 4 times 0. In this case, since x is 0, plus 5y, which is equal to 60. Now 4 times 0 is 0. And I'll be left with 5y, which is equal to 60. So then, because I have 5y is equal to 60, to get y by itself, I have to divide both sides by 5. So 60 divided by 5 gives me what? 12. Lovely. So I have when x is equal to 0, y is equal to 12. So therefore my coordinate would be 0, 12. Now I need to find it now for when y is equal to 0. So for the same equation, so 4x plus 5y equals 60. So this time I have to look for when y is equal to 0. So when y is equal to 0, we'll end up saying 4x plus 5 times 0, which is equal to 60. So therefore we'll have 4x, and then 5 times 0 is 0, so we'll have 4x is equal to 60. Then now we basically gonna have to put a situation where we try to find a value of x. So we just divide both sides by 4. So therefore x would be equal to 15. So we have here is 15 is x when y is 0. So we have our two coordinates here. Okay? Does that make sense? No, this last one is a very tricky one in the sense of it does not operate like the other equation. So y is equal to 2x. So we do what we usually do. X is equal to 0. So now x is equal to 0. We replace it, so we'll have y is equal to 2 times 0. Now 2 times 0 is equal to 0. So x is equal to 0. Y is equal to 0. So you're going to have 0, 0 as that coordinate. Now the problem is, if I was to substitute now and say y is equal to 0 and put it in this equation, I'll have 0 is equal to 2x. Now, 0 is equal to 2x, I have to divide both sides by 2 to find the value of x. Now, 0 divided by 2 is 0, which is equal to, this will cancel out and give me the value for x. So I have a value for x being 0 and a value for y being 0, which gives me back the same coordinate. And the reason why I'm getting the same coordinate is because they pass through the origin. So this line graph here passes through the origin. So it's the same x-intercept and y-intercept. So therefore, we have to use an alternative method. So just for you to catch that concept, this here is 0, 0. As you can see, it's the x-intercept and the y-intercept at the same time. So because of that, we can't find the x-intercept and y-intercept to then plot those 2 points. So because of that, we have to find another point so we could end up drawing a point. So I say that to say, you can't draw a straight line if both of the points are the same point. You have to have two separate points. So in a case like this, what you would usually do is just choose a random number for x. Okay, so for this, I'm gonna just say, since we have 6 here, I'm just gonna say 6. Okay, so I'm gonna just say, what if x was equal to 6? So in that case, for the same equation, if x is equal to 6, in essence, if I put this into the equation, I'm going to substitute the x with 6, and I'll have y is equal to 2 times 6. Therefore, y is equal to 2 times 6, which is 12. Okay, so we'll end up with 6, 12. So then I have 2 points now, 0, 0 and 6, 12. Once I have these two separate points, I could draw a line to connect those 2 points. So let's look at a graph now and see what we have. We'll take all these important coordinates and put them together on the graph. So we have 0, 6, 6, 0. That's going to draw one line. Then we're going to have 0, 12, 15, 12, 0, 12, and 15, 0. Then we're going to have 0, 0, and 6, 12. All right, so as you can see here, we have all the coordinates that we needed. 0, 6, 6, 0, 0, 12, 15, 0, 0, 0, and 6, 12. Now, the first line I need to draw is 0, 6, 6, 0. So I connect those two dots, 0, 6, which is over here, and then after I have 6, 0, and now I have to draw a line to connect them. The next one, I have to find 0, 12 and 15, 0. So then I connect those points, and then I have my next line. Now I need to do the same thing for 0, 0 and 6, 12. So I plot those points. So 0, 0, 6, 12, because we have 6 here, 6 goes up to the 12. We connect that line. So it's up to us to try and shade that region. So that particular region, I'm looking at the first one. So it says x plus y is more than or equal to 6. Remember, we focus on the y. So it says y is more than. So if it says y is more than, how are we shading?
To the right.
To the right. If you're looking at it from the x perspective. If you're looking at it from a y perspective, we could just say we're shading up, right? Above that line. So now I know it's going to be above the green line. All right. And then for the yellow, it says y is less than. So y is less than. So if I'm saying y is less than, where am I shading relative to the yellow line?
Below.
Below. Okay? Below this yellow line. So bear that in mind. We have to shade above the green line, but below the yellow line. So far, maybe inside of here would be shaded, right? So what we need to see now is how is it affected by this red line. So the red line now, it says y is less than. So the fact that it's y is less than, where are we shading?
Below.
Below. So we are shading below this red line, but between these two lines, because it has to be above the green line, below the yellow line, but still under the red line. So our shaded region, our feasible region, would be inside of here. Okay, so this is gonna be our region. Does that make sense? This here is a feasible region. So it's above this green line because y is more than, so we shade above. It's below the yellow line, so it cannot pass the yellow line. So yes, it's above the green line, but it cannot pass the yellow line because it has to be less than the yellow line because y is less than. Remember in our last video we spoke about that. So if you forgot that, you should go over that video just to make sure, because y is less than is what we are focusing on. We don't care about these numbers. We just need to know that y is less than. So we're shading underneath this here. And then for the red line, it says y is less than again. So we are shading under this red line. So that's why we are trapped inside of here. Now, because we're trapped inside of here, we have to take the vertices of this here in order to work out the optimal solution. So I want these points that enclose the shaded region. These vertices, very important. So we have 6, 0. Tell me another vertex.
15, 0.
15, 0. Excellent. So this is the next one. So we have 15, 0, 6, 0. We have two more. So you see, guys, this here is the feasible region. Can you see it now? So then the next one is 2, 4, which is right here. Okay. And then after here now, I would roughly say 4.25 and 8.5 is 1. This one here is 2, 4, 2, 4. Here is 6, 0. Here is 15, 0. So these 4 points here, 1, 2, 3, 4, enclose the feasible region. Does that make sense? Now we're going to take those vertices and literally put them in the objective function. So in other words, what we want to do is try to put these in a formula to see how they work. These vertices are from the ones that enclose the feasible region. So what I want y'all to do is to put it into this formula so we could see what the maximum profit is. So the first one, we're using 2, 4. When x is equal to 2 basically, and y is equal to 4. So if I put that in equation, it's going to be 10 times 2 plus 15 times y, which is 4. So 15 times 4, 10 times 2 is 20, and 15 times 4 is 60. Add those together and I get 80. So what I want you guys to do is, I want y'all to do it for all of these vertices to see which one would give you the maximum profit. Alright, so I did the first one with you. Take it down and try to go through it. Alright, so let's look at this here now. So the next one we could try this vertex 3. So vertex 3 says x is 0 and y is 0. So we put that in the formula, 10x plus 15y, which is the objective function. There are cases where they might ask you for the minimum cost, but in this case we're looking for the maximum profit. So in this case, we would say that 10 times 6 is 60 plus 15 times 0, which is 0. So together that's $60. If I do it for this one here with 15, 0. So 15, 0, x is 15, y is 0. Put that into the formula. So 10 times 15 plus 15 times 0 would give me 150 plus 0, which is $150. And then the last one, which is our answer. So x is 4.25 and y is 8.5. We put that in the equation. 10 times 4.25 gives us 42.5. 15 times 8.5 gives us 127.5, which gives us 170 when we add them together. So our answer is 170. So guys, notice how we did everything in this process. So we basically took this, figured out what the constraints were and the objective function. We then took those inequalities and legit found the points that would allow us to draw them. We put them on a graph. We found a feasible region, which happened to be inside of here. Then we picked the vertices. So 1, 2, 3, 4, and these vertices enclose the feasible region. And then we calculated what each vertex would give us, which would be these values here. Okay, so these values would give us the best possible solution that we can have. This one here would give us the best possible solution that we can have. All right. So guys, I'll send you some stuff to practice that you can go through and try to work on putting together what we did here. And that's it for linear programming. Okay, you guys just need to go over this and make sure you try to process it. It is one of those things that needs constant review and attention in order to do well. So don't give up on it. Continue to work hard on this and you'll see growth as you go along. All right.